This is the solution video for section 4.3, problem number 9. Find the intervals over which f is increasing and decreasing. Give the values of x for which f has local extreme values. All right, so remember, f is increasing when f prime is greater than or equal to 0, right? Decreasing when f prime is less than or equal to 0. All right, so give the values of x for which f has local extreme. Remember, a local max occurs when f prime changes from positive to negative, and a local minimum occurs when f prime changes from negative to positive. All right, and so what do we need to do? We need to find f prime. All right, so f prime of x. All right, so we want to use the product rule because I've got x squared times this thing. So x squared times the derivative of this. Now remember, this thing is x squared minus 4 to the 1/3 power, right? So 1/3 times the quantity x squared minus 4 to the negative 2/3 times the derivative of x squared minus 4, which is 2x. All right, and then plus x squared minus 4 to the 1/3 times the derivative of x squared, which is 2x. All right, so now we want to set this thing equal to 0. Now, we have one term plus another term, and so we want to factor. So you'll notice we can factor out a 2x, right? And then we also can factor out an x squared minus 4. But remember, we've got a negative 2/3 power and a positive 1/3 power. So we always factor out the lower power, so negative 2/3. All right. And so what does that mean? All right. That means we have a 1/3, and then I've got an x squared remaining in that first term. And then I've got an x squared minus 4 to the what power? Well, this is actually to the first power because remember, when I distribute this x squared minus 4 to the negative 2/3, I add those powers together. And so the negative 2/3 plus 1 gives me a 1/3. All right. And so now I have three things multiplied together to equal 0. So I'm going to set each thing equal to 0. So 2x equals 0, x squared minus 4 to the negative 2/3 equals 0. And then this thing, 1/3 x squared plus x squared minus 4 equals 0. All right. So what does that mean we have? All right. All right. So 2x equals 0. So x equals 0. X squared minus 4 to the negative 2/3. Well, this is never equal to 0 because what does this mean? All right, this means 1 over the cube root of x squared minus 4 squared, right? And of course, this is never equal to 0 because the denominator can't equal 0, right? Um, but you could get that the derivative is undefined whenever this denominator equals 0. So if we do set the denominator equal to 0, cube root of x squared minus 4 squared equals 0, right? This would make f prime undefined. All right, so I cube both sides, I square root both sides, so I get x squared minus 4 equals 0. So I add 4 and I get x squared equals 4. So x equals plus or minus 2. All right, so now remember, okay, x squared can really, x cannot equal plus or minus 2 because that would make f prime undefined, right? So x equals plus or minus 2 makes f prime undefined. Now, are these still critical numbers? Well, if 2 and negative 2 are in the original function's domain, which they are, right? Because x squared minus 4 underneath this radical is just fine. It would equal 0. So these are potential places of local mins and maxes. All right. What about this? All right. So I have x cubed 1/3 x squared plus x squared. So that's like a 1x squared. So 3/3. So 1/3 plus 3/3 is 4/3 x squared minus 4 equals 0. So add 4 and then 4/3 x squared equals 4. So now I'm going to divide by 4/3 or multiply by 3/4. So x squared equals, so if I multiply by 3/4, what do I get? Well, I get just 3. So x equals plus or minus the square root of 3. All right, now, okay, we're going to put 0, plus or minus 2, and plus or minus root 3 on our number line. All right, so if I do that, all right, I get, let's see, what is the square root of 3? Well, the square root of 3 is between 1 and 2, right? It's about 1.7, but it's between 1 and 2. And so we need to know that so that we can put our numbers on the number line. So negative 2 goes here, then negative root 3 goes there, then 0, then positive root 3, then positive 2. So it's important to note that, okay? All right, now we also want to include our factors. So 2x on the side, I've got this x squared minus 4 to the negative 2/3. Don't forget about that power. And then I've got this thing, this 4/3 x squared minus 4, all right, that we want to put on that bottom row. All right, so now I've got my 3 rows. So we want to fill out. All right, so now on the top row, I'm going to put a 0 above 0. On the middle row, all right, I'm going to put a u above -2 and +2, because remember that the derivative was undefined at those locations. And then here I'm going to put a 0 above -√3 and +√3. All right, so here I have my intervals of interest. All right, so now let's see, what do we have here? All right, so on the top row to the left of 0, so a negative number, 2 times a negative number, well, that's going to be a negative number. All right, on the right side, obviously a positive number. Okay, on this middle row, if I pick a number to the left of like -2, like -3, so -3 squared, right, is going to be +9 minus 4. That's a positive. But then when I raise it to the -2/3 power, I'm squaring it anyway, right? So this is going to represent a positive number. All right, what about in between? How about 0? 0 minus 4, right? Okay, so I get -4 to the -2/3, right? So that means I'm going to square that value. So that is going to become positive as well, right? And then, of course, when I plug in something to the right of 2, that's going to be positive. Notice this is positive because you are squaring whatever's inside of the x squared minus 4, right? Okay. All right. What about on this bottom row? Pick a number to the left of 0. How about -2? So 4/3 times -2 squared, right? So -2 squared is +4. Uh, so I get 4 times 4 over 3, right? So 16/3 minus 4, right? 4 would be 12/3, right? So this is obviously a positive number. Okay. In the middle, I put 0. So 4/3 times 0 squared minus 4, that would be a negative. And then to the right, like 2, that would be a positive as well, just like when I plugged in -2. All right. So now carry down my signs. All right. So to the left of -2, I have a negative. Uh, Here, negative times positive is negative. Here, I have a negative times negative, which is a positive. Positive times negative is negative. Positive, positive, positive is positive. And then positive, positive, positive is positive. So when is this function f increasing? Well, remember, increasing means whenever f prime is greater than or equal to 0. So we're going to say from -√3 to 0, and then from √3 to infinity. Remember, it can be less than or equal to 0, and it could also be undefined here. We have a little bit more to talk about why this thing is still considered okay. Remember, 2 is in the original function's domain, right? So yes, this is undefined. So what must be going on there? It must be a vertical tangent, right? It's not an undefined part of the original function. It's only an undefined part of the derivative. All right, so that is when the function is increasing. All right, when is it decreasing? Whenever f prime is negative. So that would be from -infinity to -√3, and then from 0 to +√3. All right, and then where are local mins and maxes? All right, so there is a local max at, well, remember, local max occurs when the derivative changes from positive to negative. So negative, negative, positive, positive, negative. All right, so at x equals 0, and that's it. All right, and then a local minimum at x equals, well, whenever we change from negative to positive. So that would be at -√3 and +√3. So that is